All right, guys. We're having now example two, and for this example, we're having a fillet weld. It's the same as previous example, but we instead of having bolts inside our place, so we replace it by having some fillet weld. So as you can see in the photo, you have here some welds here. We put it all around our plate and here 70 millimeters and 150 millimeters from that side, and also here is 70 millimeters, and the blade techniques are also shown. So we're using 6 millimeters E41 SB Fel 12. E41 means 410 megapascal, and this is a type of weld. You have SB and JB, and this is the 6 millimeters is about the thickness. So basically, what we're having something like that. So this is actually our weld, as you can see here. So this is, we call this leg or weld leg, and this is the second leg, and this is what we call it throat. So this is the thickness of the throat, we call TT. All right, so we have 6 millimeters here as identified by the question, and you can see that we're using the same both for the two legs. So let's go and see what the code say about how to determine the maximum design force N star when we're using weld. Of course, so this is for the felt welds. And when you design a felt welds per unit length, you have basically two formulas. One of them for the GB weld, and the other one for the SB welds. And the difference between them is basically the factor. So the question is all the same, but you have a different factor. If you are using SB, 0.48. If you're using GB, so 0.36. And the first element we're having FUW is the nominal tensile strength of the weld metal. It's basically what comes from the type. So when using E41, it means 410 megapascal. If you're using E48, so it means 480 megapascal. And the T is the thickness of the throat, as already I've drawn to see how you got the thickness of the throat is actually that distance. And the KR is a reduction factor. It depends about the IW. The IW is the length of our welding. So I will go and show you how to calculate the IW from the graph. As in the graph, we have 70 millimeters at the top, 150 millimeters, and then we have a 70 millimeters also. So you calculate 70 multiplied by 2 plus 150 to get how much IW you got. So it is, if it is IW is less than 1.7 meter, which 170 millimeters. So you're gonna take it one. Obviously, with our example, we just have 70, 150, and 70. So it's gonna be IW is gonna be 1 because it's less than 1,700 millimeters. And if it is more, with other examples, we might find that. So it's going to have you're gonna apply this formula if it is between 1.7 meters and 8 meters. If it's more than 8 meters, so we're gonna take the IW by 0.62, and IW is the weld length. Okay, so this is what we got. This is how to get the KR from IW, and that's it. So let's go to our example and see the factor. So the FUW FUW, okay, so FUW is going to be 410 because we're having A41. SB, this means we're going to use another with the factor with 0.48 from our code. The IW we're having is 70 multiplied by 2 plus 1 plus 150 is going to be 290. So IW is going to be 290 millimeters. All right. For our thickness, we have 6 millimeters here. So basically, you can say 6 over square root of 2 to get how much this thickness of the trough. So you got it 4.24. I got it 4.24 millimeters. All right. According that we have 290, this means our reduction factor Kr is going to be 1 because it should be more than 1.4, I think, meter to have a formula, and it's just too small for that, and that's it. So we'll go to Excel sheet and see how we're gonna calculate it. Okay. So our type is SB. What we're having here is 41, not 48. So we'll go to the top and change that. This is we're having 41. Having SB. The weld thickness 60 meters, and we're having our total. We calculated 70 multiplied by 2 plus 150. 290. So this one is 290. All right. So let's go down and say, okay, so we having the weld is A41. It means FUW 410 megapascal. And the thickness of the 424, assuming, we're going to assume in this example that we're having both equal legs for our welding. And the KR, as we're having depends on the weld length, as I said here, you can say it here. We're having 490 millimeters, less than 1.7 meter, so it's going to be the KR going to be 1. Okay, that's it. Now you just calculate it. So the result here, what we're gonna get is the result per millimeter. So how much kilonewton going to be supported by each millimeters from our weld, and to get how much N, so you just multiply this result with the 290, which is the weld length with IW, and then you got 242.136. So that's it. So you got the maximum N in the welding in our case is 242.136 kilonewton. If, for example, this actually not adequate in our design, so we have a higher N star, so what we're gonna do, you can just increase the weld size or increase the weld strength. For example, you can use 48, E48 instead of A41, and that's it. This is just for the welding in our felt weld, very simple. And in other examples, when we're having a moment, things are going to be a little bit harder because you have to calculate how much moment is going to be transferred in your plate, and that's we're gonna find out. That's it. Thank you guys.